Hello everyone, Assalamu alaikum. My name is Muhammad Mubashir Hussain, and today I'll be presenting my BSc project titled Development of a Smart Bangladeshi Indigenous Fish Classification System using IoT and Convolutional Neural Network. This project was conducted under the guidance of Professor Dr. Muhammad Osir Rahman from the Department of Computer Science and Engineering at the University of Chittagong. The project addresses a significant cultural and practical issue in Bangladesh. Fishing and local fish are deeply embedded in Bangladeshi culture, but recently younger generation are showing less interest in indigenous fish, with many unable to recognize even common types. This generational shift is a growing issue not just culturally but also for local fishermen whose livelihoods depend on demand for this fish. Many young people also struggle to identify these fish in local markets. To address this, we proposed a technology driven system to make identifying local fish easier and more engaging by offering information about each species. Let's see how this project aims to solve these challenges. Our main objective for these projects are as follows: to collect a robust, dataset of indigenous fish species from Bangladesh, to train a convolutional neural network model for accurate fish classification, to implement the trained model in an IoT system that enables classification, and to finally to develop a mobile application to make the classification system accessible to users directly on their smartphones. In the methodology part, here is our working flow. The diagram outlines the workflow of the proposed methodology, beginning with collecting images for our dataset. We process these images through data augmentation, which enhances the dataset's diversity and improves the model's performance. The dataset is then split into training, validation, and testing, for which enables the model to learn, verify, and be evaluated on unseen data. Using MobileNet V2 as our CNN architecture, we train the model on our dataset, enabling it to identify key features of each fish species for accurate classification. Once trained, the model can then predict and classify new fish images, displaying relevant details about each species. The project hardware includes a Raspberry Pi 3B, which and a Pi camera, which together serve as the primary IoT device. For deployment, we have used a laptop as a display and for peripheral management. The model used here, MobileNet V2, was specifically chosen for its balance between accuracy and efficiency, which is ideal for embedded systems like the Raspberry Pi. The software tools include Python for data processing, with a focus on compatibility with both the IoT device and mobile integration. Here are some images showing the system in action from the IoT deployment to the mobile application interface. This is our IoT device in action. We can see that in the display, which was shown in the laptop, it is properly identifying a fish. And then this is a snapshot from our system deployed on a smartphone. We can see that it is also properly classifying which fish it is. Moving on to evaluation, the dataset comprises 337 photos across 9 classes of fish species. Uh, these are divided into 2128 photos for training, 584 photos for testing, and 325 photos for validation, which ensures the model generalizes well to new data. The trained model achieved an accuracy of 93%, with a precision of 93.62% and recall of 93.15%. This high F1 score indicates that the model maintains a balance between precision and recall, effectively managing the both false positive and false negatives across different fish categories. For instance, some classes like Loita and Sol achieve perfect scores, while others like Bine and Takimas also perform very well. This strong performance shows the model's reliability in real-world classification tasks. These project's key contributions include creating a robust and diverse dataset with over 3,000 images across 9 fish categories, which can serve as a foundation for future research in fish classification, developing an accurate CNN model specifically tailored for classifying Bangladeshi indigenous fish with 93% classification accuracy, implementing this system on both IoT and mobile platforms, demonstrating its potential for scalability and accessibility. Finally, our dataset it is a significant contribution as it enables future research by focused on Bangladeshi fish species which is currently underrepresented in available datasets. In conclusion, this project combines CNN and mobile net technologies to accurately classify Bangladeshi fish species, helping younger generation engage with local fish culture. This system's multi-platform deployment ensures it's accessible to a wide range of users, both on IoT device and mobile application. Looking ahead, there are several key areas for improvement. We aim to periodically update the dataset, improving accuracy by incorporating new images, adding more fish classes to expand the model's scope, scaling the IT model to help local fishermen identify fish in real time which could benefit small scale markets, and finally, working to reduce the project costs, making it a more viable solution for local industries. Thank you, everyone.